With the previous example, we already started learning about the stretching and shrinking transformations made to a function. If we have our value a greater than 0 and a point xy that lies on the graph of y equals f of x, then the point x a times y lies on the graph of y equals a times f of x. If your a is greater than 1, if whatever value you're multiplying your function, your outcome f of x by is greater than 1, you're going to have your graph stretching vertically, which means it's going to be being pulled away from the x-axis. Let's suppose I have a parabola. This is my original graph. For my a being greater than 1, my coefficient that I'm multiplying my function by, my graph's going to be pulled away from the x-axis. If my a is in between 0 and 1, my graph will vertically shrink. And it's going to look like if somebody was pushing it towards the x-axis. Here's some more examples for whenever you have your, this is this one, the vertical stretch and the vertical shrink. Now similarly, this is when you're multiplying a times f of x. Again, I'm multiplying by my outcome, not by the input. If I multiply the input, I'm going to put it over here. If I multiply times x before I compute f of x, then my transformation, it's a horizontal stretch or a horizontal shrink. If my a is in between 0 and 1, I'll have my graph being pulled away from the y-axis. And if my a is greater than 1, my graph will be pulled towards the x-axis. And here's the visual representation. Again, if whatever value I'm multiplying my input, my x, by before I compute f of x, my graph will be pulled away from the y-axis. It's going to be stretched away. But if the value that I'm multiplying by is greater than 1, my graph will be pushed towards the y-axis. And these transformations are for when you are multiplying inside your input, or inside for the value x that you're inputting into your function.